Imagine if your computer could predict heart disease based on just a few health metrics. That's the power of machine learning. And today, you're going to build your very first ML model to do exactly that. No prior experience needed. We'll walk through the entire process together, step by step, and by the end, your model will be making real predictions from real-world medical data. To get started, make sure you have the following installed on your system. First, Python, which is the main language we'll use. Next, Jupyter Notebook for writing and testing our code interactively. And the core libraries like Pandas, NumPy, Matplotlib, and scikit-learn. Once that's all said, fire up your Jupyter Notebook. Let's jump into the code. We'll be using the heart disease prediction dataset. The link to this dataset is given in the description below. Each row represents a patient, and the columns include things like age, blood pressure, cholesterol, chest pain type, and whether or not they have heart disease. The target column is what we'll predict. 1 means the patient has heart disease, and 0 means they don't. So let's start by loading the dataset. But first, let's import Pandas library. Here we will load the CSV dataset. For this we will use pd.readcsv, then in parenthesis use R, and then the path of the CSV file. You can also see view records by using head function. Run it, and your dataset is all set to be used. Now, before we dive into modeling, let's understand the data we're working with. So first, let's look for null values in the dataset. To check this, we will use is null function, along with sum function, to know how many null values we have in our dataset. No missing values, that's good news. Once that's done, we will move to see basic statistics of the dataset. For this, we will use describe function to get a clear picture of our dataset. Now let's visualize the relationship between age and heart disease and uncover patterns. We'll start by looking at the age distribution of patients, specifically how age relates to whether or not someone has heart disease. Two tools to do this. We're going to create a histogram which will show us the frequency of patients in different age groups. But here's the twist. We'll create 2 overlapping histograms, one for patients with heart disease and one for those without it. This will help us visually compare the age trends between both groups. To begin, we filter our dataset using the condition data then in square bracket target, which is equal to 1. This gives us all patients who have heart disease. Then we select just the age column and call the hest function on it to plot the histogram. We also set the alpha value to 0.6. This controls the transparency of the bars. By keeping it semi-transparent, we can overlay the second histogram on top without one blocking the other. We label this one as a disease. Next, we repeat the same steps for patients without heart disease. That's data target here. It will be equal to 0. Again, we plot their age distribution with a different color, but the same transparency. This one is labeled no disease. After both histograms are created, we use plt.legend to show the labels on the plot. Then we add axis labels using X label and Y label, and finally give our chart a title. Here we are setting it as heart disease by age as the title. Once everything's set up, we call plt.show to display the plot. This visualization will help us see if there's any age-related pattern in heart disease, like whether older people are more likely to be affected compared to younger ones. Let's take a look at the plot and see what it reveals. This helps us see trends, like whether older patients tend to have heart disease more often. So now that we've visualized the data and understood a bit about the patterns, it's time to prepare the data for machine learning. The first thing we need to do is split the dataset into 2 parts, one for training the model and the other for testing it. To do this, we'll use the train test split function from scikit-learn model selection. First, we need to separate the features in the target column. As shown, here the target column in our dataset tells us whether or not a person has heart disease. So we'll remove that from our main dataset and store it separately. To drop the target column, we'll use the drop function and assign the result to a variable called x, which stands for the input features. The target column itself will go into a variable called y. Now we'll use train test split to divide our dataset. We'll keep 80 for training the model and 20 for testing it. This means the model will learn from the larger chunk, and we evaluate how well it performs on the smaller chunk that it hasn't seen before. This will then have test size 0.2, and we will also add random state equal to 42, just to make sure the results are consistent every time we run the code. And finally, we'll print the number of rows in both the training and testing sets just to confirm everything is working as expected. Perfect, our data is now split and ready for the model to learn from. Up next, we'll actually build and train our machine learning model. Now that we've split our data into training and testing sets, it's time to move to the next step, choosing the right machine learning algorithm. Since our task is to predict whether a person has heart disease or not, which is a yes or no, or in other words, a binary classification problem, we'll use a model that's designed for exactly this kind of task. So, for this project, we'll go with logistic regression. Despite the name, logistic regression isn't actually used for regression tasks. It's one of the simplest and most effective algorithms for classification problems like ours. To use it, we'll first import logistic regression from scikit-learn model. Now let's train the model. First, we will write model equal to logistic regression, then in parentheses, we'll set the max iter parameter to 1000 just to ensure the model has enough iterations to converge and find the best solution. Then we'll use the fit function, which takes in the training features and the training labels. We will run this code, and now our model is now trained. It has learned patterns from the training data. Now that our model is trained, it's time to see how well it performs. The first step in this process is to make predictions using the test data, the portion of the dataset the model hasn't seen during training. We'll use the predict function to ask the model to make its best guess about whether each person in the test set has heart disease or not. We'll also print out the first few predictions just to take a look. In these predictions, a 1 means the model predicts the person has heart disease, and a 0 means it thinks they don't. These are the model's guesses, and now it's time to see how accurate those guesses really are. Now let's evaluate our model to understand how well it performed. So for this we will first import accuracy score and classification report from sklearn metrics. Now here we will use two tools for this. First, accuracy score, which gives us a quick number showing what percentage of the model's predictions were correct. Next is classification report. This gives us more details, like how well the model did with each class, both people with disease and those without. So for this we will write accuracy equal to accuracy score, then in parentheses y-test and predictions, and then print the accuracy and classification report. The accuracy score tells us the overall correctness of the model, while the classification report dives deeper, showing precision, recall, and F1 score for both classes. This helps us see not just whether the model is right, but how it's right or wrong. Great job! You've now built a machine learning model, made predictions, and evaluated its performance with real-world data. Awesome work! You just built your first machine learning model that predicts heart disease using real-world medical data. In the next video, we'll learn about a new topic in data science, and that is neural network. So stay tuned and focus to master data science and AI. Hit that like button if you learned something today, subscribe for more hands-on ML tutorials, and comment below with your project ideas. What shall we build next?